This is an introduction. I'm back in my home studio. This is an introduction to how the various graphs of derivatives fit together. Please make sure you understand every step. Watch it as many times as you need. So first of all, we're going to start by stating this is our function of interest, x cubed minus 3x. Its derivative, which you could prove on your own, is f prime of x is 3x squared minus 3. The second derivative, that is the derivative of f prime, f double prime, is 6x. So the first thing I've done here is made a table of values, and basically that's just I plug negative 2 into the initial equation, and I'm going to get 2. And I've done an entire table of values for all three functions at these specific points. There's no particular reason I picked these other than they're relatively ordered. So the first thing we're going to do is take a look at the function. There's our function, x cubed minus 3x. Now, this next graph, f prime of x, is a graph of the numerical value of slope. So what I see is I have a positive slope, so it's going to be in this area up until this point. The slope there and there is 0. So when I graph those points, I'm going to have a point there, and I'm going to have a point there. And there, you can see that just relates right down, right to there. Okay, so the question is, what's going on at these other points? Well, I'll go back to my table of values. And what this says is when x is negative 2, the derivative, this equation, is 9. So that'd be negative 2 squared, 4, 12 minus 3 is 9. So what that means is at this point, the slope, right there, the numerical value, the rate of change is a positive 9. I've done these verticals by 2. 2, 4, 6, 8, so that would be right there. What that means is in this area, for this area, the slope is increasing. The function is increasing. And then you see it goes down from here to here. So that means I've now got a negative slope. Oh, and by the way, you can see the table of values at negative 1, the slope is 0, and that's indeed what it says. At negative 1, the slope is 0. Let me take another value. At 0, the slope is negative 3, so that would be right there. And then 0 and then 9. 0 and then back to 9 right there. So now this curve looks like that. And this can be hard to read. So basically what I'm doing is I'm saying what is the numerical value of slope to the left here. And you can see this whole area, all there, the function is increasing. And here, the function is increasing. Here, the function is decreasing. So basically what this tells me, if I, without looking at this, I'm going up, I stop, I'm going down, I'm going down, I'm going down, I stop, I'm going up, I'm going up, I'm going up. So that would be the derivative. And you can see that the cubic drops one order, and x cubed drops one order to an x squared, or parabola. So based on that, you would think that an x squared would drop to a line. So let's take a look at that one. There's my slope of 0 right there. So now what I'm looking at is this will be the slope of this. And we'll talk more about how this and this relate later on. But right now, that means that slope right there will be 0. Very good. Well, what's happening on this side? Well, the graph is falling. And what's happening on this side? The graph is rising. And if I look at the values, you see negative 12 is the slope, negative 6 is the slope, negative 0, then 0, then 6, then 2. So if I simply plot those points, I'm going to get something that's all the way up here. And then what do we say? Negative, negative 12, 2, 4, 6, negative 6, 2, 4, 6, 2, 4, 6, 8, 10, 12. Well, would you look at that? It is a perfectly straight line. And again, what this says is the slope here has a negative value. The function that we're referring to is decreasing. Here, the slope has a positive value. The function we're referring to increases from 0 to 2. It is increasing on this interval. You don't need to do a table. You can look at this and examine. I can see, for instance, here, I know there's a 0 there, so I plot that point. There's a 0 there, I plot that point. Correct? I mean the zero slope. And then it's rising, so that would be a positive. It's rising, but it's rising less quickly. So it's rising very fast here, and it's rising less fast. Finally, it stops and reverses direction, and then is falling through this area and then rises again, which is exactly what this initial graph says. Hopefully that'll help you understand some of these graphs.